Okay, I've just gone straight into my drawing. I will just do this last little part of angle PRQ equals A. PRQ equals A. That angle there equals A. By the way, it might be a little bit hard to see, but I've got a dot near the O, which is where my origin is, which is on the line of the circle. So maybe we can zoom in to show. But anyways, first things first, determine POQ in terms of A. With POQ, if I end up having this angle here, P to O to Q, you end up getting that arrow or Star Trek symbols looking thing. You end up having your angle over here is going to be at the center is double that of the circumference, so that's going to be 2A. So that should be fairly straightforward. That's 2A. The next part is going to be explain why angle PQS equals 2A. Angle PQS. So that would be angle P to Q to S. Sorry, I needed to have that from my first line as well. Continuing on all the way to S. I needed that for my initial drawing. Can I move the Q? Probably not. That's okay. Alright. Q we just remember is the interception point. So for that one, that is going to be because it's alternate. And the reason that it would be alternate is because we've got to be looking within circle C1. If we end up making our triangle, I'll make it a slightly different color. Probably should not go green. Any other color would be good. If we go from P to there to here, that angle that you have on the outside here is going to be the same as the angle here, because both the angles on the outside will be alternate to the angle that we established here, which we established was 2A from the previous question. So alternate angles would be the reason for that one. Alternate angles. And it is only 1 mark, so not a lot of justification needed at all for things of 2 marks and below. Okay, now prove that PQ equals QR. Now I'm going to have my working out up here. I'm just going to color in red. So we're trying to say that PQ is going to be the same as QR, which is saying that it would be an isosceles triangle, which I guess means that these angles up here would be the same at PRQ and QPR. So let's see if we can figure that out. Now the final thing that we need to do with this question to be able to solve that both of these are the same and hence this angle would be A is, just like we had figured out on the previous question that this angle on the outside would end up equaling 2A. Because this is an isosceles triangle, this angle on the outside over here would also be 2A if there was a tangent line going across. Therefore, using the exterior minus interior sum for the triangle RPQ, it would mean that you'd need to do the exterior minus the interior, and that will end up getting you your angle over here. So that would be 2A minus A equals A. And therefore, once you realize that this angle up here is A at RPQ and the angle at PRQ is also A, that means there's identical angles, it must be identical side lengths. It means it's an isosceles triangle. It means that PQ, R and P are. It means that PQ and RQ are the same. So that's how you would solve that one.